So I'm re-recording the if-else-if video that I filmed earlier today, just so that I can continue the flow of the variables video in context of that video. So we looked at what is a variable and how can they be used, and well, we looked at one way how they can be used. Another way that some of the more primitive types like the integer, the float, and char can be used are for decision trees. So in a flowchart, a decision is denoted by this diamond shape. So the program comes down, we reach some sort of a decision that we've got to make, and depending on the value of a variable, we do either one branch or another branch, or perhaps something else again. So let's take a look at an example of going to the movies and what price do you pay based upon your age. If you're a child, then you pay the child rate, and if you're a grown-up, you pay the grown-up rate. So we'll start off. I really can't draw flowcharts with this tablet, so we've got the age, and in Australia you're an adult if you're over 18, but the movie people seem to charge you the adult rate if you're 16. So let's say if your age is 15 or over, this symbol here, greater than, means if your age is greater than 15, and this symbol here, equals, means if it's equal to 15. So when you see the two combined like this, it means if you're this condition or greater. So if you're equal to 15 or over. In mathematics, it'll be written like this. So you may have seen this symbol in mathematics classes. Because this symbol isn't available on the keyboard, it's typically these two symbols combined to create this symbol. So if the age is greater than or equal to 15, then adult. And so we'll have a yes, and then out this branch we'll have a no for child. Then you'd watch the movie, and then it ends. So this is that scenario where it's a simple if your age is equal to or greater than 15. So it's a fairly simple kind of a decision, and the way how to do it would be once processing opens. So the way how we do this is we take a look at, well, if your age is greater than or equal to 15. So if age is greater than or equal to 15, pay adult. So what we're saying is, if you're greater than or equal to 15, you pay the adult rate, and else pay the child rate. So I'm just putting in this extra code that we need just to make it run. So if we're greater than or equal to 15, we pay the adult rate, else we pay the child rate. And if you've done some programming before and you're saying, hey, this looks kind of verbose, there's a lot of extra lines here you don't need, that is true, we'll cover that shortly. I've added this pay statement here as well so that we can see the variable rate, which is this string adult or child. We can see that get taken in the pay parameter, in the rate parameter of the pay function, and then we use it here like this. So there's a couple of things that are going on, and this is sort of covering those things all at once. We'll cover functions in more detail soon, probably in 1 or 2 videos time. Until then, we'll just focus on this if statement here. So what's going on in the flowchart to the left is the code in the right here. And if we click on run, because I'm 32, it'll go, is your age greater than or equal to 15? Yep, you must pay the adult rate. You must pay the adult rate. So let's change my age to be 14. And we should expect it to say the child rate. Yep. Now, boundary conditions are something that's very important to test. A boundary condition is at the point at which a decision gets made. So 15 is this point here, so it's important to test that. So we've tested 14 as one side of the edge. We're now testing the edge itself, and it says you must pay the adult rate, which makes sense if you're 15, or it makes sense to the cinema people. And then 16 will be the other side of that edge case. So you must pay the adult rate, and it still makes sense. Boundary tests make a lot more sense when we see more complex logic come in, like in loops and when we have things counting and stuff like that. For a simple if-else type scenario, you may not need to test it. And testing is a very, very big part of programming. If you don't test properly, then you get all kinds of bugs and stuff into the program code, and we generally don't like to see bugs. So this is our simple if-else statement. It is important to note that the else is optional. Having something take place if a condition is true is the required part, but you don't always need to have the else here. An example might be, an example of something like this would be, let's pretend, I'll put this back. Let's pretend I've got a scenario like if there's a big error that just happened. I can go exit and close that. And it doesn't make sense to have anything else afterwards, because this will just be the rest of the code that runs right here, and to put all of that extra code inside of a block like this just doesn't make sense. We just want to continue running the code as per normal. So we'll we'll sort of move on from this point, because I think that's pretty much exhausted everything to say there. Let's look at a more complex if-else type scenario where you're at the movies and the pricing structure is a little bit more complicated. For example, often they'll have child, adult, there'll be a student rate in there, and perhaps also a senior rate. And so seeing a decision like this, we'll have start, then we'll have the diamond, and rather than having the condition inside the diamond, we'll just have age question mark. And then we'll have less than 15, greater than or equal to 15, but less than 21. Let's pretend that all teenagers over 15, but all people less than 21 are students. Then we'll have, stuff this, I'm gonna start this again. So let's start off with our start button. Then our diamond for age. And then we branch off into one of 4 different branches. And we'll say if we're less than 15, then child. If we're greater than or equal to 15, and we are less than 21, then student. And then let's say greater than or equal to 21 and less than 64, adult rate, and then greater than or equal to 65, senior rate. That's supposed to be curvy, like that side there. So this is a slightly more complex scenario, and what's going on here is this is a shorthand way of drawing out the following flowchart with multiple decisions. What is going on under the hood is we see this less than 15 child rate. Otherwise, we've got the greater than or equal to 15 and less than 21. Then we've got the adult rate here, and then the seniors rate here. And I apologize for all of this getting kind of curvy. I'll rotate my tablet a little bit. Then we watch the movie, and then we end. So this is what's going on under the hood, and this is what the programming language will actually do. Let's actually write out the programming in two different forms. So first, let's do if age is less than 15, pay the child rate. Else, if age is greater than or equal to 15, and we've got to put in double ampersands to do a logical and. So if we're greater than 15 and less than 21, oh wait, I didn't put that. So if age is greater than or equal to 15 and age is less than 21, pay the student rate. Else, if age is greater than or equal to 21 and age is less than 64, pay the adult rate. Else, and we can assume that if you're older than 64, you are 65 or older, so you can pay the senior rate if you're older than 64. So this looks kind of large and convoluted and very nested diamonds, kind of like what we've got going on over here. We've got a lot of little decisions going on, and there's a way that we can simplify it to make it look more shorthand-like. The way how we do that, it relies upon a little trick within the programming language itself. Whenever you see the if statement, the very next thing that gets executed is what will happen if that is true. And that very next thing can be as simple as one statement, or it can be a block of code, and you start a block of code with these open brace and close brace like that. So we can do that step to simplify it just a little bit. Now let's take a look at the else statement. The else is what's going on in the opposite case. So if the condition is true, we do this statement here. If the condition is false, then we do the next thing that's a block. Now, because it's a block, and it consists of only the if statement as the next thing to execute, we can get rid of it there, and then we want to get rid of, I think it's that one there, and then we do that. And all I'm doing is making it appear flatter. And so we can see how this fairly flat looking structure looks like this flat looking structure here. And we can do that largely thanks to the shorthand within the language itself, based on we're only executing one block ever. So else only executes if, and that if only executes the next pay, and then that, if that turns out to be not true, then we revert back to the previous false, and then so on and so forth. So it becomes much flatter, and it appears more natural. It looks a lot more like how we naturally think. If you go to the movies, the cashier doesn't go, okay, your age is greater than 15, so I'll move on to the next tree. Oh, your age is greater than this, so we'll move on to the next tree, and your age is less than this, so you're paying the adult rate. No, they just go, okay, you're between this range. So if we run this, I'm expecting it to say the adult rate. Yep. So let's test the boundaries. Let's pretend I'm 14. Child rate, yep. Let's do 15, and so this should say the student rate. Let's do 16, it should still say the student rate. Now let's do 20, because that's the next boundary, it's up here. And it should still say student. Yep. If we did 21, we're now expecting it to say adult. Yep. So let's do 80. And we're expecting it to say senior. Senior rate, yep. So this is what we call the else if control structure. There are a few other control structures that we haven't covered. There's the switch statement, and that one is a little hard to do with simple examples like going to the movies. I'll do a separate video on the switch statement. So there's switch. The other control structure that we can do are loops, and loops are great for when you want to repeat the same task over and over, but you don't want to write it out. Like if you've got to mix a cake and you've got some code to say run the cake mixer for 1 revolution, and you have to mix the cake mix up 500 times, you don't want to copy paste that 500 times. You want to be able to say, okay, while the counter is less than 500, let's keep mixing, and then increment the counter once per mix. But I'll cover that in the next video, and I'll try and think up a good example for the switch case control structure as well. But yeah, there's 2 kinds of loops that we'll do next, and probably the switch case after that. Thank you for watching.